Hi every student, you have learned how to calculate the oxidation number of an element in a compound in the previous lesson. In this video, you will learn how to explain with example the oxidation and reduction processes in terms of the change in the oxidation number and in terms of the electron transfer. Most redox reactions occur without involving hydrogen or oxygen. For reactions that do not involve hydrogen or oxygen, we can find out the oxidation and reduction reaction in terms of change in oxidation number of an element or transfer of electron. Let's look at example 1. When hot iron wool is burned in chlorine gas, it will form iron 3 chloride. The oxidation number of iron elements at the beginning of the experiment is 0. After the reaction completed, the oxidation number of iron elements changed to positive 3. So there is an increase in the oxidation number of iron elements from 0 to positive 3. So we can say ions had undergone oxidation. On the other hand, the oxidation number of chlorine element is 0. At the end of the experiment, the oxidation number of chlorine elements decreases to negative 1. So, at the same time, the chlorine has undergone reduction. So this is an example of a redox reaction. We can study the same chemical reaction in terms of electron transfer. The half equation for the oxidation of ions, we can see in the half equation here, ions atom lost 3 electrons to form iron 3 ions. So iron atom had lost electron during this chemical reaction. It means iron undergo oxidation. On the other hand, the half equation for chlorine is Cl2 added with 2 electrons to form 2 chloride ions. So chlorine molecule had gained electrons donated by iron atom. So chlorine had undergone reduction. In this reaction, ions act as a reducing agent and chlorine act as an oxidizing agent. Let's study example 2. In this reaction, chlorine had displaced bromine from potassium bromide solution. Let's find out the oxidation number of each element before and after the reaction. Before the reaction, the oxidation number of chlorine element is 0. After the reaction, negative 1. Potassium elements, positive 1 before the experiment. After the experiment, remain unchanged, still positive 1. For bromine, the oxidation number before the reaction is negative 1. After the reaction, 0. So we can see clearly the oxidation number of bromine increases from negative 1 to 0. So we said bromine had undergone oxidation because the oxidation number of bromine increased. And on the other hand, the oxidation number of chlorine decreased from 0 to negative 1. So chlorine had undergone reduction in this chemical reaction. And the oxidation and reduction occurred simultaneously in this chemical reaction. So this is a good example of redox reaction. If we study the same chemical reaction in terms of electron transfer, we can derive two half equations from this chemical reaction. The half equation for bromine is two bromine ions lost two electrons to form bromine molecule. So bromine ion had lost electron in this chemical reaction. So we can say bromine ions, or the name of the compound, potassium bromide, undergo oxidation. On the other hand, the half equation of chlorine is written here. Chlorine molecule gains electron in this chemical reaction. So chlorine had undergo reduction, redox reaction. Example 3. Magnesium burns in oxygen to form magnesium oxide. The oxidation number of magnesium elements is 0 at the beginning of the experiment. At the end of the experiment, the oxidation number of magnesium elements changed to positive 2. So we said magnesium had undergone oxidation. The oxidation number of oxygen elements before the experiment is 0. At the end of the experiment is negative 2. So we said oxygen had undergone the reduction. Now we try to study the burning of magnesium in oxygen in terms of electron transfer. We can derive two half equations from this chemical reaction. The first half equation showing that magnesium atom lost two electrons to form magnesium ions. So we said magnesium undergo oxidation. On the other hand, oxygen molecule gains 4 electrons to form 2 oxide ions. So we say oxygen had undergone reduction. So this is a redox reaction. Now let's study the neutralization reaction. We try to find out the oxidation number of every element in this chemical equation. The oxidation number of hydrogen element before the experiment is positive 1. After the reaction completed, the oxidation number of hydrogen is still positive 1. The oxidation number of chlorine elements negative 1. At the end of the experiment, negative 1. The oxidation number of sodium element at the beginning of the experiment is positive 1. At the end of the experiment, remain as positive 1. How about oxygen? The oxidation number of oxygen is negative 2. At the end of the experiment, remain as negative 2. So the oxidation number of every element remain unchanged before and after the chemical reaction. So this is a non-redox reaction.